All right, here we go. And like last time, the quiz may not have this many problems on it, but every problem on the quiz will be on this sheet, okay? But it may not be all of these. All right, here we go. Sine 7 pi over 6. What are you thinking when you see 7 pi over 6? 30 times 7. That's exactly right. Very good. 180 divided by 6 is 30 times 7 is 210. You do not need a calculator for that. You can do that. So this is the sine of 210. Okay, now what are you thinking?
Go around 210.
Go, where is 210? That's right, you're going to graph 210. So we start here, go around 210 is going to be about right here, right? So my triangle is going to look like that. Remember, this is 180. Now what? It isn't 60. I got to find this angle, but it's not 60. What is it? 30. Because 210 is 30 degrees past 180. Label these axes, people. You're just getting started. You're new in your trigonometry journey. So label those to kind of clue you in. Okay? By the way, you'll never really use 270 because remember our angles are always built on the x-axis. So 180 is always our kind of starting point. I'll just erase that. All right, now I know that's a 30. So my sides are 1, 2, root 3. Would you agree with that? Now, notice I'm doing this without my cheat sheet, right? You have until Tuesday. You've had the sheet for over a week, and now you have until Tuesday to get that down. Okay? So, all right, so there we go. Oh, by the way, I'm not in quadrant 1, so what's negative?
Yeah.
The x and the y. They're both negative, right? I knew that was going to happen. In quadrant 3, they're both negative. Oh, that'll be an interesting little thing for those people. Okay? Yeah. All right, so what's my answer? I want the sine. By definition, sine is either y over r or opposite over hypotenuse. Either way, so the answer is -1/2. Read.
How do you know the negatives and positives again?
Okay, you're in quadrant 3. Here's the origin. X is negative, y is negative. It depends on the quadrant you're in. Hypotenuse is always positive. Hypotenuse is always positive. All right, what are we going to do with 270? Where's 270? Straight down. Uh-oh, it's quadrantal. So when you have a quadrantal angle, you do not draw a triangle. When it's quadrantal, we have no choice but to do it in a circle. I'm using a radius 1 circle. You can use whatever radius you want. If I use a radius 1 circle, then this point has what coordinates? Here's the origin, straight down. What would that be? 0, -1. So x is 0 and y is -1. X is which variable, x or y? X. Cosine, oh there I give you it. Cosine is x, right? Cosine's associated with x. So your definition for cosine is x over r. It's also adjacent over hypotenuse, but that won't work without a triangle. So x over r is 0 over 1, so the answer to the problem is 0. 0. Tangent -7 pi over 4. Tangent -7 pi over 4. We've done a few of these now. What's pi over 4? 45. So you have 7 45s. So you may need to do that over the side, but the arithmetic is easy. What is that, 315? So we're finding... Yes.
Jacob's to the zoo.
Oh, thanks. Thank you. Okay, so we need the tangent of negative 315. Is that right? All right, so you're going to draw a picture, but it's negative angle. So remember, nothing changes except you go this way. So 315 would put me over here like this. Every quadrant's 90, 90, 180, 270. I gotta go past 270. So my angle looks like this, perpendicular comes straight down. Now, if this is 315, this whole part, what's left right here? 45. And what do I know about the sides of that triangle? 1 root 2. That's exactly right. Now, do I need to worry about negatives this time? Nope, because luckily I'm in quadrant 1, so everything's positive, and I want the tangent. So I can either use opposite over adjacent or y over x, whatever I want to do. Remember, this is x, this is y. So whichever definition you want, it turns out to be 1 over 1, doesn't it? So the answer to the problem is 1. Now, find the smallest positive and negative coterminal angles for 119 pi over 5. Now, you know that to find coterminal angles, you either add or subtract revolutions, right? That is a very big angle. So I'm going to change it to a mixed number so I get a better feel for what it is. So 119 divided by 5 I got 23 and 4/5, but I don't know, did I divide right? 23 and 4/5. So that means I've got 23 and 4/5 pies. Now stop and think about this for a second. What's a revolution in degree or in radians? In radians, what's a revolution? 2 pi, right? So if I want to find the smallest positive angle, I got to get rid of some of these extra revolutions. So in other words, I got to get rid of a bunch of 2 pi's. Well, if I start with that 23, forget the fractional part for a minute, just start with the 23, and I start taking out 2's, eventually what am I going to have left? 1 pi and 4/5, 9/5. Does that make sense to everybody? That this is going to shrink down to 1 and 4/5 pi because 23 pi's, well, 22 pi's is 11 times around. So I get rid of that 22 pi, and that leaves me with 1 and 4/5 left. So think about that for a second. 1 and 4/5, or 9/5, as Tyler said. It doesn't matter to me how you think about it. Now I need, oh wait, that's the answer. Isn't that the answer to the question? Isn't that the smallest positive angle I could come up with? Right? So what did I do? I subtracted out all the 2 pi's until I couldn't subtract anymore. If I subtract another 2 pi, I'll be negative. So the negative coterminal, this is the smallest positive, the smallest negative will be negative pi over 5. because 9/5 minus 2 pi is 9/5 minus 10/5, or negative 1/5. So there's my smallest negative, and there's my smallest positive.
What do you get negative 10/5?
Subtract 2 pi. Remember, to find coterminal angles, you add or subtract revolutions, right?
Yeah.
This one started out so big, I had to subtract just to get it down to be the smallest positive number that it could be. Okay, number 3 has a star, so it's a calculator problem. So I'm going to find the length of a shadow of a 32-foot pole if the angle of elevation of the sun is 28. See if you can draw that picture. It's going to be a right triangle. See if you can draw it and label it.
Two studies. One of them I call Montauk Point, the goals, and the other I call Montauk Point, the sea. The sister captain sat down beside me on the couch.
Mrs. Wood,
Yes.
what page are we on?
We're on the practice quiz 4.1 to 4.3.
Okay.
A man named Gatsby. Do you know this?
You got a picture drawn? Let's see, I'm missing Haley and Ellie. All right, let's see if your picture looks like mine, or if my picture looks like yours, I guess I should say. Here is my 32-foot pole. Here is my angle of elevation. And I want to find the length of the shadow. Tell me that's what your picture looks like. Beautiful. So, now I need to find x. So I got to decide which function I'm going to use, because in these problems, you're always going to write a sine, cosine, or tangent equation. So which one do you think we should use? Tangent, because we have opposite and adjacent. So we'll say tan 28 equals 32 over x. Clear the fraction and divide. Remember, you're solving for x. So you're going to type in 32 over tangent 28. By the way, I don't know what you did last on your calculator. Would you make sure it's in degrees? This is a degree measure. So 32 divided by tan 28. Yeah, we'll round to the nearest hundred and put a unit on it. So that would be 60.18 feet. All right, the next one is also a calculator problem. It says we have a wheel with a 10-inch radius turning at 510 revolutions per minute. RPM is revolutions per minute. So that's what I'm starting with, 510 revolutions in 1 minute. That's my beginning. And I'm ultimately going to end up with miles per hour. That's what I'm going to have to end up with. Okay? The key to this, the confusing part of this is people forget that a revolution is a circumference. And for a 10-inch radius wheel, the circumference would be 20 pi inches, right? That means every time it goes around, a revolution covers 20 pi inches. Think about taking this wheel, putting a blob of white paint on it, and rolling it down a black driveway. Won't you see white dots? And how far apart will those white dots be? A circumference. So, I say a circumference 20 pi inches, all right, inches, is 1 revolution. Okay, now I need miles. Clearly gonna run out of room. I need miles. So let's see. I know that there are 1 foot is 12 inches. And remember, my goal is to get this stuff to cancel out, so that's why I'm arranging it like this. And then I know that there are 5,280 feet in 1 mile. So now I have miles. If you notice, feet are canceling, inches are canceling, revolutions are canceling. Now I've got miles per minute. So I need to get hours out of that. So I'll go up this way to get hours out of that. I know there are 60 minutes in 1 hour. So now my minutes will cancel, and I am left with miles per hour. Right? So I'm going to type it in on my calculator. Everything on the top, just multiply straight across. So 510 times 20 pi times 60. That's the top, right? All the numbers in the top. Now I'm going to divide that. And since I've got 2 numbers down there, I'm going to go ahead and divide by parentheses 12 times 5,280. And this wheel is spinning at 30.34 miles per hour. All right, 5 does not have a star, so we need to be able to do 5 without a calculator. Remember, the quiz will be front and back, so you won't be able to squeeze the calculator in if it's a no calculator problem. Cosine is √3 over 2. Find the angle in radians. Well, I hope you're thinking about this triangle right here. Theta is at the origin, which is where it always is. Now tell me about this triangle. If the cosine is √3 over 2. 2 would be the hypotenuse. √3 would be the adjacent. So COTOA should be written at the top of your paper to help you remember. By the way, if I write something at the top of my paper, I'll write SOHCAHTOA, and then right underneath it, I'll write cosecant, secant, and cotangent, and that will help me remember what goes with what. Okay, well, what angle is that? If the √3 is here, there must be a 1 here, so the answer to that problem is 30 degrees. Oh, wait, it needs to be in radians. Some of you have already, I mean, this is all clicking together, so you know it's pi over 6. If that doesn't make sense to you, and by the way, pi is 180, and 30 is a 1/6 of 180, so that's why it's pi over 6. But you always can go back and do pi over 180 equals x over 30. You can always go back and set up your proportion and cross multiply. Number 6, the sine is 4/5. Find the tangent. Well, I drew the triangle there for you, but it's the same one we used before, right? There's nothing special or different. You should know to draw that triangle. And the sine is 4/5. It is here. I need the tangent, which means I'm going to need to figure this out. How do I do that? Pythagorean Theorem. Now, if you happen to recognize a Pythagorean triple, then you don't need to go through the math. But if you don't recognize it, you'll say x squared plus 4 squared equals 5 squared. So x squared plus 16 is 25, x squared is 9, and it looks like that is 3. So now we can answer the question, what's the tangent? 4/3. Seven is an arc length problem. What's popping into your head when I say the word arc length? Radius times radians. That's exactly right. Look at the problem. What's wrong with it? It's degrees. So if we want to use that formula, we'll need to change 120 into degrees. Now, some of you, again, you already got it figured out. It's 2 pi over 3. Because 120 is 2 60s, and a 60 is a third of 180. But if that's too much, you'll say pi is to 180 as something is to 120. So x is 120 over 180. And 12 over 18 reduces to 2/3. So your arc length is simply 5 times 2 pi over 3. So 10 pi over 3. If there is a unit on the radius, so if that had said 5 feet, then that would be the unit on the arc length. All right, 8 obviously is a calculator problem. What do you need to remember before you can even start typing here? Oh, I erased my little cheat sheet down here. Cosecant is the reciprocal of the sine. So if I want a cosecant, I'm going to have to type 1 divided by sine. Literally type. Hector, you okay, man? Want to sit up? We have a quiz on next time. 1 divided by sine, and then I do 128 second angle degrees, 19 second angle minutes, and 32 alpha plus. And I got 1.2747. And there's 10,000. Does that look right? Okay, one more, and then we'll move on in our notes. Find the angle of depression of a squirrel looking at a nut on the ground. Okay, so we got here's our squirrel looking at the nut. He's in the top of a tree, 19.5 meters tall. And the nut is 103.2 meters from the base of the tree. We had a problem like this in our homework, and some of you did not put the label or put the number in the right spot. This clearly says 103.2 meters from the base of the tree. If it said 103.2 meters from the squirrel, that would be the hypotenuse. All right, and what am I looking for? The angle of depression. Technically, up here, we can always put it here. Angles of elevation and depression can go right here. What function are we using? Tan. So we'll say tan x. Angle always goes with the function. Tan x, sine x, cosine x, always. Equals 19.5 over 103.2. How do I type that into my calculator? Secant tangent, right? when you are looking for the angle, you have to use the second button. Some of you are looking at me strangely. We talked about this. I'm positive we did. So, secant tangent, 19.5 divided by 103.2. And the angle is 10.70 degrees. Well, that was fun and exciting. So let's,
Mr. Ward,
yes.
could you kind of explain how the tangent has like the -1
You
attached to
type
it?
secant tangent on your calculator.
Well,
So
like,
you,
how does
I
it
think you were
become-
absent. Have you watched the video from that day?
Maybe not then. Yeah, probably it is.
Yeah, watch the video. Okay. Now, so that's our quiz. Now we gotta get our notes out because we got some material to cover. And we have to at least get through this page. All right, so here we go. We're on page 44 of our notes. And we have done, in fact, there's a problem on the quiz that's kind of like this. There's a little bit of an additional twist this time. So here's what I want you to notice. They tell us what the cosine is. So we had a problem on our practice quiz where I gave you one of the functions and asked you to find another one. And remember what you did? You drew your triangle and you did the Pythagorean Theorem and you found your answer. Well, this is a little bit more complicated because not only do I tell you what the cosine is, but I tell you that the tangent is negative. So you really have to think, because before and on the quiz, you just automatically drew this triangle and said this is 2 and this is 3 and then went from there, right? That can't happen in this problem because the tangent is negative. And nothing is negative in quadrant 1, right? So while this is your first instinct and it's perfectly okay, you need to figure out where to draw the triangle so that the cosine can still be 2/3, but the tangent will be negative. So I see Josh going like this. Josh is saying, well, what if I drew the triangle down here? Would the cosine still be 2/3? Yes, because x is still positive, right? But now, when I do my Pythagorean theorem, this will be negative, and that will make the tangent a negative number. So let's go ahead and do the Pythagorean theorem. Tell me what you get. Remember, that's the hypotenuse. So if you're getting root 13, you're doing it wrong. 2 squared plus x squared is 3 squared. Did you get negative root 5? 9 minus 4? Now I can answer the questions. This says, what's the sine? So looking at that picture, what is the sine? Exactly. So the sine of theta is negative root 5 over 3. What's the cotangent? The cotangent. Thank you. 2 over negative root 5, which is negative 2 root 5 over 5. Right? Well, there's another one like that. Let's see if we can figure it out.
How do you figure out which quadrant?
Okay, well listen, I'm going to do the next one, but you just have to be aware of what's positive where x is positive and where y is positive.
So, do you not have to add them?
I don't have to what?
Add them?
No, it says find sine and
Oh.
cosine. I don't need plus, yeah, or cotangent. I'm just, yeah, find those two things. All right, so the next one says a sine is 1/5. Now, my gut instinct would be to draw my normal triangle and label it like that, right? That would be the normal. But it says the cosine is negative. So basically, what is that saying to me, Reed? It's saying y has to be positive, but x has to be negative. Where does that happen? That y is positive, but x is negative. Quadrant 2. Now, how do I know that? Because I have memorized that sine is associated with y, and cosine is associated with x. Those things have to be ingrained in your brain. They just have to be, or you can't figure this out. Okay? So I need y to be positive and x to be negative. So that happens not there. That happens in quadrant 2. Y is positive, but x, whatever it is, will be negative. So the combination of these two things tells me what quadrant I'm in, because it gives me information about y and it gives me information about x.
So, I have a question.
Mm-hmm.
So, did you say that sine is y and cosine would be x?
Yes.
Okay.
Look at your yellow sheet. Sine is y over r, cosine is x over r.
Okay.
Okay, now I need to figure out secant and tangent. Secant and tangent. All right, well, first I need to figure out what the missing side of that triangle is. So has anybody done that yet?
-2√6.
-2√6, exactly. It's actually the square root of 24, but when you simplify that, you get -2√6. All right, so secant. What's secant? Reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. So 5 over -2√6. Oh, I'm glad this happened, because some of you had trouble with this in your homework too. When you rationalize this, because there's a radical on the bottom, okay? When you rationalize it, you're going to multiply the top and bottom by √6. And that's going to give you 5√6 on the top. What do these make right here? 6, but it's times 2. So it's not 6 on the bottom, it's actually -12 in this problem.
Yep.
And that's the secant.
Could you leave it square root 24 or negative square root 24?
No, you gotta simplify. Yeah, you gotta simplify. We went in lowest terms. Okay, and I also want the tangent. All right, so what's the tangent? Well, I'm gonna do the same thing, aren't I? Because the tangent's going to be 1 over -2√6. So I'm going to get √6 over -12 as my tangent value. All right? Things get more complicated when you move out of quadrant 1. But this is the way it is. All right, let's look at the next one. Cosine is -1/2. Now let's do this in degrees first, because most of us anyhow are more comfortable in degrees. So let's start with degrees first. Your job is to find any angle, all the angles in the whole wide world that have a cosine of -1/2. Now this is not a calculator problem. We're doing this without a calculator. So the first thing I want you to do is tell me where those angles will be located. You all know it won't be quadrant 1, right? Because in quadrant 1, you don't have any negatives. The fact that it's cosine negative tells me x is negative. Where in my coordinate plane is x negative? Quadrant 2 and quadrant 3. Both of those triangles would have negative x values, right? So I'm just going to label the top one for a minute. This would be negative 1 and this would be 2. Agreed? This then would be root 3. I'm just looking at the top one for a second because the bottom one's going to be the exact same. They're congruent triangles. They're exactly the same. Now, what can you tell me about this angle right here, the reference angle? If that's a 1, that's a root 3, and that's a 2. What is the measure of that angle? 60. Now, 60 degrees is not an answer to this problem because our answer has to be in standard position, which means it has to start here. So this is one of the angles that you are looking for. How big would that red angle be? 120. So one of the answers to the problem is 120 degrees. Now, there's another one. It's this right here. But this little angle right here is also 60. They're always going to be the same because the sides of the triangle would be the same. But again, 60 is not an answer. How big would that angle be right there? Not 210, although you're in the right ballpark. 240? How do I know it's 240? Because you went 180 and 60 more. To get to the blue line, I had to go 180 and 60 more. So I have another angle that's 240. Now, will there be any more triangles that I could draw? Could I have it over here or here? No, so that's it. Except, we not only have those two, but we have all of their coterminal angles. So to find coterminals, we simply add and subtract, revolutions. So we're going to add and subtract 360n, where n is some whole number. So you're adding and subtracting 1 360, 2 360s, 3 360s, and so on. And the same thing with this one. So when it says list all of the all of the angles whose cosine is -1/2, this is the answer in degrees. Now just to prove it to you, take out your calculator. Oh, let's try this one. What's 240 plus 360? 600? Type cosine 600. What's it say? Yeah. All of these angles, any of these, if you type them in on the calculator, cosine of them, you would get -1/2. These are all the angles. Now, it says we also have to do it in radians. Okay? So this is a little bit different. I mean, it's no big deal. We just have to change these to radians. Right? We're not redoing the problem. We're just going to change these to radians. So pi is to 180, as something is to 120. I think I just did this. So x is 120 over 180. Yeah, I did. That's 2 pi over 3, right? So 2 pi over 3 plus or minus what? I won't say 360, 2 pi n. So these are exactly the same. This one's in degrees and this one's in radians. Uh-huh.
Do we have to write that NEW?
N is an element of the whole numbers. You should, so we know what n is.
Okay.
This just means n is a whole number. So like 1. So this is 1 2 pi, or 2 2 pi's, or 3 2 pi's, whatever. All right, now I gotta do the same thing with 240, so I'm just gonna cheat a little bit since I'm about out of room. So that makes this a 240. What is that reduced to? 4/3. So the other answer, the radian answer is 4 pi over 3 plus or minus 2 pi n. That is a hard problem. You have to think a lot to do that. So, let's try the next one. Somebody tells you that the sine of an angle is √3/2. What is like the first decision you need to make? What quadrants? Exactly. So stop and think about it for a second. Sine is y. That's a positive number. So where am I going to be? 1 or 2. So you're going to have a triangle in 1 and a triangle in 2. So the two answers to the problem are going to be this angle right here and this angle right here. Those are going to be the two answers. Now the reference angles, this little guy right here, the red guy, and this little guy right here, they're always the same. The reference angles are always the same. So let's just focus on finding one of them. I know the sine is √3/2. Is that enough? Can you tell me the reference angle? 60? 60? Because that's a 1. Now that means this one's also 60. They're always the same. The reference angle is always the same. So this time is 60 an answer? Yeah, because I'm sitting in quadrant 1. So one of my thetas is 60. What's my other one? What would be the blue one? 120 again. Yep. Now those are the main two in the main, one revolution. But if we want all of them, we'll say plus or minus 360n. And this is all of the angles that have that sign in degrees. Now I've already done this one a couple times today, so 120 is 2 pi over 3. What's 60? In radians, I mean. Pi over 3. And then I add 2 pi n when I do my radian measures. Okay, well that one didn't seem quite so bad. That's the first one. So here are my 2 degree answers, and here are my 2 radian answers. All right, well, we're so fortunate. There's 2 more of them. Let's see. Tangent equals 1. Tangent equals 1. Alright, so you are first figuring out where you're going to draw this. Yes?
How do you know that it's like, for the radian, like 2 pi over 3, how do you know you put the plus minus 2 pi in?
As opposed to what?
Like, how come it's not, how do you know that like you put that instead of another number, like 4 pi?
Because you add and subtract revolutions. And a revolution is 360 or 2 pi. Now, the 4 pi is covered because n can be anything, any whole number. So if n were 2, you'd be adding 4 pi.
Okay.
If n is 3, you'd be adding 6 pi. All right, what quadrants is the tangent a positive number? 1 for sure. Josh is back there with his index finger up. Absolutely, if you're positive, you're in quadrant 1. Where else though? Which one? Negative, negative. Not 4. 3. So this time, your two angles are this one. Remember, you're in standard position. So you start on the x-axis and go around till you get to your angle, your ray thing sticking out. So I need to figure out the blue angle and the red angle. Okay, well I know the tangent is 1, so does that labeling there make sense to you? How big is that angle? 45. Which means this one's 45. Which actually means that the blue angle is 45. But what about the red angle? So one of them's 45, okay. What about the other one? What'd you say? How did we get 225? You're exactly right. Exactly. When you draw this angle, don't freak out, and for Pete's sake, don't memorize crap. Use your common sense. To here would be 180, and we're going 45 more. So 180 plus 45, perfect. There are your degree angles. Now, if we need the radian ones also, we need to change these guys into radians. Anybody know what 45 is? Have you done enough that you have that memorized yet or not? Pi over 4. It's pi over 4. Again, if you don't have that memorized, that's fine. That isn't something I necessarily want you to focus on memorizing. But after you do them so many times, you start remembering. But you can always do pi is to 180 as x is to 45. Or now I have to do 225. Exactly. So x equals 225 over 180. Which is 5 pi over 4 when you reduce it. And some of you really think about it for a second. To get 225, didn't you take 180 plus 45? So in radians, wouldn't that be pi plus 1/4 pi? So 1 1/4, 5/4. So that's another way to think about it. All right, these are tough, no question about it. One more. Oh, this one's really hard. Sine equals 1. Oh boy. Tell me about sine equals 1. It's on the circle. Very good. Now, you know, we're brand new at this trigonometry stuff, so you're thinking, okay, sine equals 1 over 1. So you're thinking, okay, it's in quadrant 1, opposites 1 and hypotenuse is 1. Is that possible? Can the hypotenuse ever equal a side? No. So what you're just discovering is you can't draw a triangle. If you can't draw a triangle, then you must draw a circle. And we know, if the radius is 1, we know what all these points are. Right? We also know that sine is y over r. So r is 1. Period. Every single point here has an R of 1, so I'm not worried about that. I just have to look around the circle and figure out where the Y is 1. Where is the Y 1? at 90. So my answer, that's the only place, right? So not theta is 90 degrees plus or minus 360n. Okay? So any angle coterminal with 90 is going to have a sine of 1. Now, what's 90 in radians? Pi over 2. Half a pi, pi over 2. Look at what I almost did, not 360. 2 pi n. Now, I don't want you to think that when you use the circle, you only get one answer. Sometimes you do. But if this had been a 0, then I would get an answer up, or an answer over here and an answer over here, right? So depending on the number, you still can get 2 answers. We only got 1. None of what we talked about today is on your quiz, guys. What we just did was hard stuff. That is not on the quiz. The quiz is what I gave you. That's what you're going to practice. Definitely keep this stuff in your mind, though, because we're going on from there. But you are doing a great job. If you have any time between now and Tuesday, please spend that little bit of extra time making sure you understand the basics of the yellow sheet. Because on Tuesday after the quiz, we're going to the other side of the yellow sheet, and we're going to do some graphing. Okay? All right, Michael, would you be so kind? Oh, Lord. That needs to be done for sure. Also, guys, I know when I start rattling on and on and on, some of you tend to zone out. You can't afford to do that because you have to pay attention to know what's going on, right? Solar? It's all confusing. But it's worse when you play with your water bottle and don't focus.
I was focused.
Yeah, the first one wasn't
Just my ADHD.
What? Okay, as long as you're focusing, I don't care if you play with it. All right, guys, we're done. Quiz next time, okay? We also, don't forget, on Monday morning, guys, we don't have class Monday, but we have office hours at 8. They're virtual, but we have office hours at 8. No, that's the next week. Yeah. All right, see you guys. What? Okay. I'll mark it down. All right.
Well, we don't hang out.
Yes. What?
When would we take it?
Take what?
The quiz.
The next quiz? On Tuesday.
Oh, okay.
When we have class. Yeah. The one we just practiced? Yeah, that's Tuesday. The very next class.
Literally the only thing you learn in the entire semester is how to make stuff supply and demand. Literally, that's all you learn. I still do.
Oh, shoot, did I? Oh, my videotape all that.